Here are some typical power requirements as of 2025. If you look, we see the CPU. Generally, today's CPUs will use about 150 to 200 watts of power. A typical motherboard will use anywhere from 40 to 70 watts. RAM, around 30 to 50 watts. Now, RAM is getting more and more efficient. The voltage is lower on each new version of DDR that comes out. However, it's still going to use a good amount of power. And if you have multiple sticks of RAM, that's going to increase the amount of wattage. The GPU is the big draw. Here we see 250 to 350 watts. That's if you have an actual card, an actual GPU that you're using that's separate. And if you have your GPU built into the motherboard, it's going to be less than this. So here we're talking about an actual GPU card, and I'll show an example of one in a little bit. Storage drives today are very efficient. They don't use that much power, between 5 and 15 watts. The older 2.5-inch SSD drives are very low power usage. NVMe drives use a little bit more, and they can get a little bit hot because of that. And in fact, all of these devices can get pretty hot, so you have to be careful with that. We'll talk more about that as well. Finally, PCI Express expansion cards could use anywhere from 10 to 30 watts. Not a huge draw, but still something you want to calculate when you're deciding on a power supply to use for your system. And for expansion cards, we're talking about network interface cards and sound cards, that kind of thing. Let's take a look at the MSI Power Calculator website. So there's a bunch of power supply calculators out there. This is the MSI power supply calculator. I just did a build recently and used a lot of MSI components. And so they have a calculator on their website. Let's go through it real quick. We'll select the CPU. I'll say Intel. The socket. We'll go with the build that I just did, and I'll show some images of this build in a little bit. LGA 1700 and the actual processor. I didn't go with the latest processor. I went down a couple of versions, and this is the one I used here, the Core i7 12700KF. And usually I'll do that. Usually I'll go down a generation or two to save money. This is still a great performer though. Now you'll see once I select that, we get the recommended PSU wattage here. We're at 239 watts so far. Next is the GPU. We've got an NVIDIA version, and I got an RTX 3060 for this device. Only one so far. It would be cool to have two. But look what happens to the wattage. It jumps up to 555 watts here. Now we'll go to memory. I have DDR5, and we have 2 sticks of RAM in this system. That brings us up to 585 watts, which is pretty much what we were talking about in that table. Additional PCI cards, I don't have any, but let's just say you had one in a buy one slot. That's not going to use too much more power, about 10, 15 more watts. We're up to 597. Storage drives. Well, I have 2 M.2 drives in here, so I'm going to select that now. That brings us up to 617 watts, so about 10 watts each, thereabouts. Optical drive, no, I'm not using one in this system. You never know, I might add one, but probably not. Fans, I do have 5 fans altogether. And also PD, that's power delivery, and that's for fast charging through a USB-C device port, which this system also has, and that's going to increase the wattage. So you can see here now our recommended PSU wattage is 722 watts. And then what they do is they give you examples of recommended power supplies that you could use. And they're going at 750 watt power supplies for this, which is slightly higher than our maximum draw. Keep in mind that you're not always going to be drawing 722 watts. You're only going to be drawing what you need for your CPU and your GPU and so forth. if the computer is sitting idle, the current draw will be a lot less. Now, I like to over-engineer, and you probably know this about me. I don't think 750 is quite enough if I'm going to be maxing out at 722. I always like to over-engineer a little bit, so I actually purchased an 850 watt power supply for this particular system. If I was to add a second video card, look what happens. Even the 850 watt power supply would not be enough. I would have to switch it out. But as it stands, with one video card, we're good at 722 watts. So that's the MSI power calculator, and it works very similar to other power calculators out there. So there you go. We used the power calculator, and it held true pretty much to our typical power requirements that we're showing here. And here is the system I built for this video course. This is the CPU under here. It's got a giant heatsink and fan. And then here is the GPU, which is in a by 16 slot. The M.2 drives are underneath these heat sinks. This is where the primary one is, where the operating system is installed. And this has two ports for M.2. I'm only using one right now, and that's where additional data will be stored. The RAM is back here. You can't really see it too well, but there's 2 sticks of DDR5 RAM. And this is just another view from an angle from the right, so you can see it. So it was a fun build. If you're into PC building, this is some cool stuff. And I document how I did the build step by step on my website at prouse.tech/A+. Here's another image of the system booted up, and you can see the fans have lights on them, LED lights. I did that just for fun, but you can see the whole system is up and running and ready to go. This is an ATX form factor, and the power supply actually goes down here underneath. It's good to have airflow. Now, we mentioned you have all this power that you're using. In this particular system, as much as 722 watts max at any time. The more electricity you use, the hotter your components are going to get, especially the CPU, the GPU, and those M.2 drives, and even your RAM. So you need to be able to cool your system. We talk about cooling in other videos, but just real briefly, here we have 5 fans. This is the front of the case, and we have 3 fans built in. Then on the CPU, we have a fan, and then we have a fan on the back of the case. The idea is to take air from the front of the case, and that's going to be the intake, and the airflow is going to go in this direction and out to the back. So you want to make sure that your fans are facing in the correct way. If you're looking at the front of the case, the fan blades should be shown in a convex look. You should be looking at the convex side if you're looking at the front. So if you're looking at the convex side of a fan, the airflow will go away from you. And that's the idea here. With this case, didn't really matter. It was installed properly, these 3 and this 1. But for the CPU, we had to put the fan in correctly so that the airflow would go in this direction. So this here would be the convex side. And on the other side, on the back, you have the concave side of the fan. Got to make sure that airflow is going in the right direction to get your maximum cooling benefits for all those hot devices. If I was to add any more devices, I'd probably move to liquid cooling, but that's not really necessary with this particular system. So there you go, a little bit to think about: power calculations, new systems, heat, and airflow. And that's it for this video.